Thank you. So today I'm going to talk about like evaluation of the countermeasure to improve pedestrian and bicycle safety using dynamic survey. So gonna go now over the overview. First, we're going to talk about the motivation, about developing and evaluating such a countermeasure and the objective, the previous works that has been done, and also what we have reported in the beginning, and how did we evaluate it. That's through stage 1, stage 2, and we end up with some conclusion. So, Jacob, if we go to the next next slide, yeah. So the motivation is like, actually, first we did like some like a trivia about what's going on about like the pedestrian bicycle fatalities. So we have found like pedestrian crashes represent about 1.1 of the total crashes in US, but actually there but it represents about 14% of total fatalities. So and between 2004 and 2014, this fatalities increased from 11 to 14%. And also there is a study that has been done in Wisconsin, found that 28% of fatal crashes are driver not yielding to pedestrian. And out of these, 68% were with the driving going straight, and 18% with the driving are turning left. So the second reason, or second cause for crashes at intersection was driver were trying to turn left and hit a pedestrian. Thank you, Jacob. Next one. So the third motivation, like we try to analyze, okay, what's the factor that affects pedestrian crashes at intersection? And we found that there's a different factor. So the first one, like driver were like unable to detect the hazards or like a failure injector hazards. That's due to the complexity of driving task. That also includes like a type of turning maneuver. So like turning left associated with higher mental load, workload, especially with like old driver. So thank you, Jacob. Next one. So now we come with a kind of an objective. Okay, so we have these causes, and we know like, okay, turning left, one of the second major cause for accidents at pedestrian accident at intersection. So we have to come like kind of like develop and evaluate what kind of countermeasure that can be addressed, especially for vehicles making a permissive left turn at signalized intersection. And we came up with a way to test this countermeasure using a dynamic survey. So previous work. So there's a different effort that has been done to enhance detection of pedestrian, especially at intersection. But most of these work were considering right-turning drivers only. These devices include flashing pedestrian indicator, FBI, the yellow pedestrian border, the supplemental signal warning right-turning motors, and flashing turning vehicles leading to bikes. I will talk about it next. So. Yeah, so flashing pedestrian indicators, as you can see here, like this flashing indicators, like it's flashing or like alternative between the pedestrian icon and the yellow icon here. So so when pedestrian trying to cross the intersection, she has to press the button and starting to have like kind of this kind of alternative warning. So this study has been done in Florida, and actually it is only like a driving simulator study. And one of the issue with it, like, they found like the through drivers had some confusion about it. Like, some through drivers thought, okay, they may expect pedestrian in front of them, so it has some disadvantage. So let's go to the next one. The yellow pedestrian borders. This is actually a real application that has been done in California, where like and actually it's a small town in California that like when pedestrian push the button, you can see there is like a yellow border there, and it is like kind of a solid yellow border. And it has been implemented in California. There's no publication has been found like about it, like what's the real benefit of it and stuff like that. Although like the people or the municipality there said people like it, and like as a term of acceptance, people like it. But I don't know about the time, like the effectiveness of this device. So next, Jacob. The next one is a supplemental warning signal. This signal has been implemented like and used in Germany, and it's a supplemental yellow flashing warning right turning for pedestrian. And when it has been used in Germany, like when the motorist view or driver view for the of the crosswalk and the right is obstructed, like maybe like tree or something that may not help the driver to see the pedestrian. So next, Jacob. This is the last one, like the flashing turning vehicle into bikes. Actually, this device has been used in Portland, Oregon. What they have two loop detectors. One loop detectors for a bicycle and another one for a vehicle. So when the loop detects both a driver and a bike, so starting can have like a solid warning, which is a presentation of one of the MUTC signs. So yeah, and it's one for the right turning right turning drivers of a bike in the bike's lanes. Yeah, next. Okay, so to begin, develop, and evaluate countermeasures, we had to go and to find what kind of methodology that we have to use, or something we could use it based on. And what we have found, like Adapted American National Standard Institute has a methodology for evaluating a new and develop like a new warning signs, and develop and provide the guidelines for evaluating safety samples that starting with reviewing existing samples and developing a set of potential designs. Next. So evaluating so this methodology have two stages. First stage is screening. We test different proposed design and through a multiple choice question, and the aim of this screening tools is like eliminating weak candidates that either confusing or have a poor subject comprehensions. The second stage is kind of confirmation. So what we do is like, okay, from these from the designs on stage one, we had four design, and we selected two. Then we take it to the stage two is kind of confirmation, as it is an open-end questions require the subject understanding of the design. I will talk about it the the proposed design. So actually what we did is like we had many many iteration trying to develop these devices, and what we came up like 4 designs. So the aim of this design is okay to warn drivers making permissive lifting. So I'll tell you about what we are trying to do. Okay, so as a driver trying to turn left, you are focusing your attention totally on the oncoming vehicles and the opposing traffic. So that may yield to higher workload. That also, you may, as a driver, not able to detect pedestrian because you are focusing your attention on oncoming vehicle and trying to find a gap. The other way, like, okay, maybe you are not focusing on environment. For example, like, I will give you an example, like at night, there is no vehicles and you just turn left directly. Your intention, your workload is very low so that you are not able to see pedestrian on the left side of the intersection. So the aim of this proposed design to be a device that can be activated by pedestrian push button, or it can be developed like for the next stage. Maybe have like a pedestrian detectors that activate automatically. So let's go next. So this is the design one. As you can see, I want to talk about this design a little bit. So the aim of the design, as you can see, like in the overhead on the left, you see like a warning, kind of a flashing warning between yellow arrows and a pedestrian icon. So the aim of the sign, okay, is kind of like there's a pedestrian on this intersection. So if the pedestrian push this button, this design or this traffic device will start activated. So what we have done, we had it like, if you see it on the left side of the intersection, we make it on the right of the traffic signal itself, because we don't want the driver or the pedestrian to be confused with this sign, So because the pedestrian may think it is like the sign for him or her that okay, now we could go and stuff like that. So yeah, if you go to the next, please. And the second design, as you can see now, we made it like inside the traffic signal. So like alternative flashing between the pedestrian and the yellow arrow. Let's go to the second design. So in the third design here, as you can see, what we have done, we have used a similar design that had been implemented in Oregon. So, and what you can see here, like the traffic device are like flashing, turning vehicles, yield to pedestrian. So we have implemented only on the left, because I think if you implemented like in the overhead, may gonna yield high momentum force that may not, or the current traffic signal may not able to handle this high momentum. So yeah, if you go to the next one. Yeah, so what we have done is, okay, as you can see, this is the R1015, which is an MUTCD sign, and this is a sign what we have used it and modified it to implement it in our third design. If you go to the fourth design, please. Yeah, so the next one is a bit it is traffic device that flashing pedestrian crossing. Yeah. So if you go to the next one, yeah. So the stage one, as I told you before, the aim of stage one is like a screening tool to eliminate weak candidates that either confusing or have a pure driver comprehension. So what we have done, we had a tablet survey, a dynamic tablet survey, and we inform participate our subject about the contents and intent in the message. So what we did, okay, so in the beginning of the survey, we have indicate what's gonna be the sign and what we are aiming to do, and ask them, okay, could you please rank the order, their preference of different alternatives. Then, and out of these four, we have selected two, and we take it to the second stage. So, in this stage, we have used Qualtrics, and this is a tablet survey. So, I want to stop here actually in Qualtrics, and I want to talk about it a little bit, and some of the outcomes that we got from this project. So, Qualtrics actually, it is not a paid advertisement, but it's very good tools actually for building survey, especially for a kind of a dynamic survey. And what we did is, first we had like the Windows Surface tablet, and we have used it through Qualtrics. But when we changed it from Surface to iPad, we found like people like it much better than Surface. So I think like what kind of tools, I mean, like the solid tools, may gonna have effect. And yeah, and also the other thing, like Qualtrics have the option to have like an app on the iPad, and you could download your survey on the iPad and work on it like offline. And after you're done with collecting your survey or your studies, you could upload it to the website, and from there you can modify it and work on it. So now come back to the survey. So the survey has two sections. It's a dynamic demographic section, then a ranking of proposed designs. We have collected driver license facilities in Madison and Wisconsin, and actually it was not short studies. It took almost like a month to collect these surveys. So I will talk about this next. So as you can see here on the screen, this is what we ask the subject. Okay, different studies have shown that drivers who are turning left may miss pedestrian bicycle crossing on the left side of a signalized intersection. Given this potential safety issue, different designs are being proposed for a new supplementary traffic signal indication to warn drivers about the existence of pedestrians on the left side of the intersection. First, you will be shown 4 potential traffic signal designs. Then we will be asked to rank the signal. That's the best way to convey the message to you. Let's go next. So this is a message. That was the message we provided. Could you please, Jacob, make it the full view or something? Yeah. So, no, sorry. Can you go back? Back again. Yeah, I don't know. It's not moving. So let's go next. Yeah. So this is a question. At the end, we ask him, okay, please rank the questions. As you can see, the 4 different designs that has been posted, like a small portion. So in the beginning, we show them the message, then we show them the full the full overview of the design itself. Then we show them like a small section of the design. So then we ask them to rank few preferred designs or the best design that convey the message to you. So let's go next. So actually almost like 260 responses or 259 responses has been collected. What we have done, we computed the mean ranking of each designs, and what we have found actually is very interesting. Like design 1 and 3 were the more preferred design. This is design 1, as you can see. This is design 3. Let's go next. So demographic of responses, as you can see here, for example, for the age, we have kind of middle-aged drivers were well presented, but for the younger and old driver are actually like kind of under presented, and actually we had a large number of males. So we get like almost like 76% of subjects were male. Yeah, and it could be the same, be kind of uniform, and like in terms of like hours of driving weekly and highest level of education. Yeah, so as you can see here, for design 1, the mean was almost like 2.18, and for design 3 it was 2.5, and this is actually as the mean of ranking. Let's go next. So as you can see here for design 1 on the upper left, almost like 30% of 32% said they give it like the give it like 1. It's like most preferred design. Then as you can see for design 3, to get like 35% to they give it 1. But on the other side, people did not like it. I mean, almost like 30% give it like 4. So yeah, let's go next. So what we have done here is like based on like the design and the age and each age group. So for design 1, the lowest design 1, like for driver who age between 18 and 65 age old and the age of 65. So the mean was the lowest on for design 1, but for driver who are older than 65, the mean were the lowest at design 3, which is 2.3. Based on the gender, both male and female give the lowest mean on design 1. So now let's talk about stage 2 or methodology of stage 2. So from these 4 designs, we have selected 2 designs, which is design 1 and 3, and we tested again. And again, the survey has 2 sections, demographic section and an open-end question required text input from the subject. And it was the same. We did it at driver license facilities in Madison, Wisconsin. So if you go next, as you can see here, this was the question. If you remember, like in stage 1, we give them what was assigned and what we are trying to do and ask them to rank it. But here, we give them the sign. Then ask them if you want to turn left and you see a signal indicating that that is showing, what you will do. So we ask them like to type it in the text box below, and but this is what we did for design 1 and design 3. So let's go next, Jacob. As you can see here, the design 3. Okay, so let's go next. So actually we have collected 122 responses and of subject, and as you can see here, also the same middle-aged driver well represented, the younger and older driver actually underrepresented. But in the opposite here, we have kind of uniform sampling of male and females. We have like 47 and 52%. So let's go next. So what we have done in the question, we ask them the meaning of a sign. So then we ask them. Then what we have done is like we went through each of these answers and we have coded whether the driver have fully comprehends the meaning of the sign. So if the driver understands that, or said, for example, I have to aid to pedestrian when I see the sign, we said yes, which is mean he totally understands the meaning of the sign. If said no, something else, we said no. So for design 1, people who said yes or fully understand the design were almost like 60%. On the other side, for design 3, people who understand the design was almost like 73.8%, 74%, which is a much higher percentage. If you go next. And when we divide it by the gender, as you can see here it is almost the same representation. So the male have understand design 3 much better, and also it can be said too for design 3, with female like design 3 much better, or understand design 3 much better. If you do it by age, as you can see, for subjects between 18 and 65 years old, they like design 3 much better, and you could see not like understand design 3 much better, and you could see for design for drivers or subjects who's older than 65, you could see clearly the difference between them. I mean, design 1 almost like although like small numbers, but you can see like 8 of the drivers could not understand the meaning of design 1, while almost like while in the other side design 3 also was only 5. So yeah, so let's go next. So I want to talk about the conclusion here. Sorry, maybe I'm being gone. Yeah. Yeah, let's go back a little bit. Yeah, this is the conclusion. Yeah, sorry. So what we have done, we haven't identified 4 designs, and from in the survey stage 1 for screening tools, we have found like design 1 and 3, which is you can see it here again, the most promising designs. And we have done in stage two. We have asked a subject about ranking these devices. Not ranking. I mean, stating understanding of the meaning of these designs, and we found like although like design one, people have liked it more or like prefer it more, but we found that design three was most comprehended design than design one. So here we have reached the end. So actually, if you have any question, yeah, please ask.
Great presentation, Ibrahim. What is the next stage of this project? Do you plan on getting these signs in a driving simulator and see how people respond?
So I think yeah, for sure, we may gonna take it to driving simulator. I think using driving simulator will give us another perspective. Just not it's not about like understanding whether like only gonna understand or comprehensive sign, but we may gonna see another element like use the eye tracker or see what's gonna be the speed profile or these kind of things or different elements that will help us to understand the effectiveness of the design much better. So um, yeah, I think like stage one or stage two were a good step forward, developing traffic device or proposed traffic device that can be used in driving simulator. So definitely, yeah, for sure we're gonna take it to driving simulator.
Okay, well, if no one has any other questions, I think we will conclude the webinar for today. Um, Thank you for joining and thank you for being patient while we worked out some of those technical difficulties. Um, I know we'll be taking a few week break from webinar. SaferSim will be taking a few week break from webinars. We have a summer CUTSI meeting and driving assessment conferences that we'll be attending over the next couple weeks. But you can look for future announcements for webinars to still be sent out. And our next webinar will be July 10th, and that is from Gary Gaffney and Tim Brown from the University of Iowa, and they will be talking about their drug driving research study. So keep an eye out for that. Once again, if you have any other questions about Ibrahim's project, you can send him an email. And thank you for attending. Have a good day.